Good morning. Happy Monday, guys. um, I am giving you guys a little bit of time to finish kind of exploring this, but I wanted to make a video and give you guys some notes for the medians, and then I'll also post another one for the altitudes. So bear with me. I'm trying to get my printer to work, and so if you hear noises right now, it's just because the printer's working. But we will go through. I had some interesting things go on with the median. I don't know if you guys really quite understood what I was asking, and I think that could have been the problem. A lot of you guys kind of just didn't even measure. From what I saw, maybe you guys did, but just that idea of exploring and kind of seeing something new. We had a couple people say that the medians created isosceles triangles. And as we'll see here in a second, an isosceles triangle can have medians in it, but it doesn't have to be isosceles. But then we also had students say that it was created a segment bisector, which is true. But the reason it creates a segment bisector is because if I create a midpoint, sorry, I was just looking for midpoint. If I create a midpoint on AB and then I create anything that goes through D, it's going to be a segment bisector. So it's not that it's wrong, it's just not that interesting because we actually made this segment be a segment bisector. We're looking for stuff that just happens without us actually trying to do it. And so again, we're going to do this for each one. A median is a segment that goes from I lost it again. That goes from the midpoint of one, so E, to the vertex of the other. So if I take my segment from E to B, then right here is actually going to be the centroid. And again, if I do my midpoint, just to show you guys that it is a point of concurrency, I do end up getting that point of concurrency right there, which we will call G. And as I move my triangle around, I see that it doesn't have to be isosceles. But a couple of you guys did say, which is good, that G always is in the middle. You have to be careful with the middle. But whenever the centroid is the one that normally is talked about as being the middle and of a triangle, and that's because it's also called the center of gravity. So if we were balancing something to put a point right at G, it actually balanced the triangle. If we're looking at this, we kind of want to look at what we might see that is interesting. And what we are going to actually do is I'm going to encourage you guys to measure the distance from E to G and then G to B. So we see it right there, 2.4, 4.8. 2.4 is half of 4.8, meaning that this segment GE is half of the entire segment GB, which is cool and is what we're going to use, but let's go ahead and make sure that that is always true. So no matter where I move this, is it always half? 2.3, 4.6, 2.8, 5.6. Let's see if I can get it exactly to 1 and 2. So now we have 1 and 2, which is nice, but it also shows us another thing, that it's not GE is not only half. The distance from the midpoint to the centroid is not only half the distance from the centroid to the vertex, but the distance from the midpoint to the centroid is also 1/3 the entire length. I could put another one in here. So that's actually one of the things we're going to use, but we're going to use all of them in here for that thing. And it's not only on there. If I measure from GC, and then also do GD, 2.8, 5.6. And so no matter what, all of these distances, the distance from the midpoint to the centroid is going to be the same as from the centroid to the vertex. So that is what we're looking at. I will I do need to give credit to some students. Some of you guys out there actually found something that I'm not even sure was true. But if I make some other triangles, someone pointed out, a couple of you guys pointed out that this is 6 triangles. And so if I go ahead and fill in that triangle, and then I fill in this other triangle, and then I even go ahead and fill in this triangle, what we will see is that those are all different looking triangles. These two might be the same, but the area for all of them are equal. And a couple of you guys noticed that out, and I don't know if you found how you guys found that out, but I think that's really cool. I didn't even know that, to be honest with you. So yeah, good work. I hope you guys are continuing to finish this out. Answer the questions that follow down here in the Go Formative, and then watch the Ortho Center video.